So for 21, I'm going to look and see which values, the x or the y values, are the ones increasing by a multiple. So if I look at 21, I can see that we're multiplying the y's each time by 1/3. So that means it's exponential. And when your x is 0, that's your a value. Because for an exponential, we've got a times b to the x. So this is going to be 1/3 to the x. For b, I see that we're multiplying here on the x values, which means it's a logarithm. And that value that we're multiplying by is going to be our base, so that is log base 5 of x. So then for c, multiply by 2, multiply by 2. Here's our initial value, so this is 2 to the x. And then for d, we're multiplying by 1/10. We don't write a logarithm with a base of 1/10. So if I think about going in this direction, that's multiply by 10, and that's a reflection. So we can make that negative log base 10 of x. You can always check your answer by substituting in one of the points to make sure your equation works. All right, for each column, choose the interval choose the interval in which solution lies in column 2. Okay, this is like matching. So for A, that's saying 2 to the x is going to be 18. Well, I know that what's close to 18? Oh, 2 to the 4th is 16, and 2 to the 5th is 32. So this x has to be between 4 and 5. So this is between 4 and 5. Okay, for B, 3 to what power is 10? Well, 3 to the 1st is 3, and 3 squared is 9. Oops, that's a 2. So it's going to be really, really close to the 2, and then into 3, so that's this one, between 2 and 3. Okay, for C, that's saying 10 to what power is 20? Well, 10 to the 1st is 10, and 10 to the 2nd is 100. So that 20 is between 10 and 100. So that's between 1 and 2 here. And that leaves the last one, 0 to 1, or 5 to the negative x. If we want to think about that, not doing process of elimination, that's like 1/5 to the x equals 1/6. So 5 to the 1st is 1. I'm sorry, 5 to the 1st is 5, and 5 to the 0 is 1. So 1/6 is between 1 and 1/5. All right, change this to a log. So this is going to be log base 4 of 16 equals 2. B is log base 10 of 1,000 equals 3. And this one, so for C, that's saying the ln, which is base E, of 1 is 0. So, okay, so now the other way for 24, for A, that's 10 to the negative 2 is 1/100th. For B, the base here on the ln is E, so E to the negative 1 is 1 over E. And then for C, 9 to the 2 equals 81. Okay, evaluate in 25. So A is saying 3 to what power is 9? That's 2. B is saying 4 to what power is 1/16th? So 1/16th is 4 to the negative 2. So our answer here is negative 2, because once your bases are the same, your exponents are equal. And this is saying to what power? C is 10 to what power is 10,000. So if you count those zeros, there are 4 of them there. D is E to what power is E? Well, that's 1. 6, is 6 to what power is 1? Anything to the 0 is 1. F is E to what power is 1 over E? It's going to be negative 1. 4 to what power is 8? So for the 4 and 8, if I can make those bases the same, I will get my answer. So let's see, 4 and 8 can both be a base of 2. So now I can set my exponents equal and isolate the W. So that is 3 over 2. And then lastly for H, 100 to what power is 10? The square root of 100 is 10, so that is 1/2. You could also make the bases the same. Set your exponents equal, 2W equals 1, and you'll get 1/2. Okay, for 26, is it growth or decay? This one is decay because the base is between 0 and 1. The same logic for B, it's decay. If I change my exponent to be positive, then the base is between 0 and 1. Or if we look here, 3 would be growth, but then this negative x is a reflection, making it decay. So then C, that's growth. The base is more than 1. Okay, so for 27, we have to pay really close attention. It says that we have to write our equation in terms of t for years. So A, 300 is our initial value. It's a continuous growth rate. You have a formula sheet. You can use it to your advantage. So 300 is our initial value. Continuous, we use the equation that has a base of E. Change your percent to a decimal, and there's our variable time. Now for B, our initial population is 2,000, an annual rate of 11%. So our initial amount is 2,000, 1 plus 0.11 to the t. You could add the 1 plus 0.11. I know it's a no calculator question, so that's 1.11 to the t. Now for C, it's a compounded monthly. So his money, he puts $500 in, change your percent to a decimal, 12 months in a year, and the exponent is 12t. Okay, so now for D, decreasing at an annual rate. That's dear. Our initial amount is 700. 1 minus, because of the decreasing, 0.08 to the t. Okay, so then we've got continuous decay. So for gnats, let's use G. Our initial amount is 4 billion, so I'm going to use 4. E, and now it's decay, so it's a negative exponent, 0.12 t. Okay, so now for 28, solving. Your answer must be exact or expressed to a decimal at least 3 decimal places. I'm going to leave mine exact because I don't have a calculator on this screen recorder. To start, I'm going to change it to a log. Then we're going to add 2 to both sides. And then divide by 3. So this is your exact answer. Okay, for B, we have to start by dividing by 5. Change it to a log. And then subtract 4. So negative 4 plus the ln of 55. All right, the graph below shows these hours and people that heard a rumor. What is the average rate of change between 0 and 2? So that's really just asking for the slope. That is 75. And our units is people per hour. Okay, so B is write an exponential function. A, our initial value is 100. Now we need to figure out the base. So we're going to multiply by the base twice to get to 250. That means 100 times the base equals 250. Solving for that, we can divide by 100. And then square root both sides. And if you use your calculator for the square root of 2.5, you get 1.58114. I know that's a really long decimal. This problem, you can use your calculator. They don't give us information about rounding. So I'll do 1.58 to the x. Okay. So similarly, we're going to write an exponential equation. And to get our base, 5 times the base 3 times is going to be 40. Divided by 5. So the base is 2. Our initial value is 5. And there's our equation. All right. Looking at the word problem, what is the continuous percent rate? Well, that's up here in the exponent. So as a decimal, it's 0.25, which is 25%. All right, 2012 is 2 years later, so we're going to substitute 2 in for t. And then you're going to use your calculator to simplify. And I get 82.436 tons of flour. All right, to the nearest hundredth of a year, when will the company have manufactured twice as much as they had at the beginning of 2010? Well, if they started with 50, twice as much is 100. So we're going to divide by 50. Change that to a log. And divide by 0.25. And that is 2.7 7 years after 2010. Okay, compounding. How much money will he have in an account after 4 years? So let's write our equation first. And then we'll substitute in 4. And you're going to use your calculator. You should get $4,030.57. Okay, so we need all 4 of these functions for 33. Write the function that has that property. So I think what I'm going to do is make a sketch of each function to begin with. This is 2 to the x, log base 3, 10 to the negative x is a decay, and negative ln x this way. And we have asymptotes. Here's a horizontal asymptotes on the exponential, vertical asymptotes on the logs. Okay. The graphs have horizontal asymptotes at 0. Oh, that's f and h. Range of all real numbers are the logarithmic ones, so g and p. Increasing the entire time, so that is f and g. For increasing and decreasing, you have to read your graph left to right. The graph has a y-intercept at 0, 1. That is both of the exponentials. The domain is positive real numbers. That is the logarithmics. Has a vertical asymptote, also the log graphs. The function has a domain of all reals, that's the exponentials. Decreasing would be h and p. Has x-intercepts, those are the log graphs. And the range is positive real numbers, so that is f and h. All right, transformations on e to the x. Translated 1 unit to the right. So that's an exponent of x minus 1. So then for b, if the asymptote has an equation at y equals negative 4, down here, what that means is our graph was moved down 4. Reflected across the x-axis is a coefficient of a negative 1, and the y-axis means the x value gets multiplied by negative 1. Okay, then e dilated by a factor of 2, so that's a vertical stretch of 2, so that's 2 e to the x. All right, what happened here in f? Our asymptote got moved down here, so this is down 5. And instead of increasing, it's decreasing, so that was reflected over the y-axis. So it's going to be e to the negative x minus 5. Okay, so then for g, hasn't been moved down at all, but it looks like our first nice point is over here at 3. So that's to the right 3. So that's e to the x minus 3. And the minus 3 is in the exponent, so it's e to the x minus 3. Okay, same idea, but with a logarithm. Translated 2 units to the left. So that is log base 2 of x plus 2. You must have those parentheses. If you don't, it's not correct. So the asymptote was moved over here to positive 2, which means it went to the right 2. So there's to the right 2. Reflected across the x-axis is a leading coefficient of a negative. Across the y-axis, we make the x variable negative. Okay, so then we have a vertical shrink of a third. So that gives us a coefficient of a third. All right, let's see here for f. The asymptote was moved over here, so that's left 3. And then for g, our asymptote stays the same, but our nice first point got moved down here to down 3, and it's been reflected over the x-axis. So that's negative log, and then down 3. Okay, fill in the blank. The value of b must be greater than 0, but it cannot be 1. An exponential function has a horizontal asymptote at y equals 0. The domain is all real numbers. The range is greater than 0. And then it's increasing, so if our base is more than 1, our graph will be increasing. If our base is between 0 and 1, it's decreasing. And the y-intercept is at 1. Oh, but it says at a point. So I'm going to write it as a coordinate, 0, 1. Okay, now for a logarithm, the value of b must be greater than 0 but not equal to 1 again. It has a vertical asymptote, and its equation is x equals 0. The domain is x is greater than 0, but the range is all reals. The function's decreasing when the base is greater than 1. It's going to be decreasing if the base is between 0 and 1. And the x-intercept point is over 1 and up 0.